Okay, here we have problem number 89 from chapter 5. So we have here crate of the weight Fg is pushed by a force P on a horizontal floor as shown in the figure. The coefficient of the static friction is μs and the Ps directed at an angle theta below the horizontal. Now you have to show that the minimum value of P that will move the crate is given by this equation. So let's solve only part A. The part B I'll just leave it for you. If you have any question, I can explain to you later. Let's look at the part A only. Okay, here we have a box crate. Okay, now it's on the rough surface. We have here a force pushing in this direction, but it says that this force actually directed at an angle theta below the horizontal. So that means we can say that it is pointing. We can just transfer this force in such a way that it's here. And this angle of theta from the horizontal below. Now, since the object, the box, is stationary and it's trying to move in this direction, so therefore it's not trying to move, so our friction force or static friction pointing in this direction. We also have here the weight of the crate, which is Fg. Okay, now we also have a normal force, which is pointing upwards. Now let's write down the equation. We know that in order to be a static friction, we have to say that static friction is equal to the applied force, which is P, in x direction, because we have to consider only the x component, okay, in this case. Now, if that's the case, then we can say that our P force has to be resolved into two components, right? The one component will be this one, which is Px is equal to P cos theta, right? Another force should be pointing downwards, which is Py is equal to P sine theta. Okay, now if that's the case, then let's write down the forces for the x component and forces for the y component. Let's write down first of all for the x component. Now, sum of the forces in x direction is equal to MAX, right? So since we know that there's no motion, there's no acceleration, so this thing will go as a 0. Now let's write down all the sum of the forces in x component. In x component, what we have? We have Px, which is equal to P cos theta, right? And then we can say that it's sum of the forces here, P cos theta minus static friction is equal to 0. That means we can say that P cos theta is equal to Fs. Okay. Now what about the y forces? No, sum of the forces in y direction is equal to MAy. So since object is not moving, we can say that it's equal to 0, and then we can write down sum of the forces in y component. And sum of the force in y component will be normal force, which is pointing upwards, positive, minus Fg minus P sine theta, which is equal to 0. Okay, then we can say that our normal force is equal to Fg minus, okay, plus P sine theta, like that, right? So far we have this formula, then here we have that formula, right? Then we can say that P cos theta is equal to static friction. Now the formula of the static friction is mu s normal force, right? If you plug the numbers, if you plug this formula, then you will get mu s is equal mu s multiplied to the Fg plus P sine theta. Okay, now let's try to bring this P sine theta on the other side of the equation. Then what we will get? We will get that P multiplied cos theta minus mu s sine theta is equal to mu s Fg. Now let's divide both sides by cosine theta. So, divide by cos theta, divide by cos theta. Then what we can get then? We can get P1 minus mu s tangent theta equal to mu s Fg multiplied to sec theta. So that means finally we can say that its P is equal mu s Fg sec theta divided by 1 minus mu s tangent theta.